In the previous presentations, I explained what blockchains are. In this presentation, I will explain how blockchains are used in practice. Here you see the table of contents of this presentation. In the first slide, I will explain how you can see a blockchain as an immutable data store. In the second slide, I will explain how blockchains are used in practice. In the third slide, I want to give a comment to people who do not believe in blockchains. Blockchains have their use and they're here to stay. In the fourth slide, I want to explain Bitcoin. In the fifth slide, I want to explain Ethereum. In the sixth slide, I want to explain how Ethereum is planned to evolve over time. And in the last slide, I want to explain the costs you make whenever you write to the Ethereum blockchain. You can see a blockchain as a place where you can write data to with the following properties. Whenever you write data, you have to pay, but once you've written the data, you can read the data for free. The data is stored forever and the storage is for free. This is unlike traditional storage solutions where you have to pay for storage. The storage of the blockchain is free because validators who maintain the blockchain have incentives to do so. The incentives of the validators are the cryptocurrency of the blockchain, and this cryptocurrency has value because people who want to write to the blockchain have to buy this cryptocurrency to pay for writing to the blockchain. So as long as people are willing to keep writing to the blockchain, the cryptocurrency of the blockchain will have value and the validators will have incentives to maintain the blockchain. If storing data to the blockchain or if data on the blockchain were seen as a book, you could make the following analogy. Then writing a book would cost money, but once you had written the book, everyone could read the book for free and the book would be stored for free forever in a library. That's how a blockchain works. In practice, blockchains have their uses. They're not used for everything. So on the one hand, you have people that believe that blockchains will solve everything. On the other hand, you have people who think blockchains are a fraud and they are not useful at all. So these two extremes are both wrong. I represent them by the images you see there. So to the one, you can use the expression, to a man with a hammer, everything looks like a nail. And to the others, you can use the expression, you should use the right tool for the job. So you shouldn't be pushing nails in wood with your finger. You should use a hammer for hitting a nail. So to come back, blockchains are not good for everything, but they have their use cases. You have to distinguish between private blockchains and public blockchains. Private blockchains are blockchains that are shared between different parties and they are used for tracking things that they move around between them. So typically this is for logistics data. It could be for anything that moves around between different parties and for which you want to keep track of where it is and where it comes from. Public blockchains at this moment are mainly used as an alternative to money. So the main use case of public blockchains at this moment are cryptocurrencies. In theory, public blockchains could be used for anything. So any data of high value that doesn't have a lot of storage and processing requirements. It cannot be used for any data. It cannot be used for multimedia like photos, videos or music because multimedia files are big and big files cannot be stored on the blockchain simply because it would be too costly. So technically it can, but there is a cost associated with it and storing data on the blockchain is very expensive. I will come back to this in the future in another slide in this presentation. To give a comment to the people who do not believe in blockchains. Blockchains have their value. Some properties of blockchains are, well, if you look to cryptocurrency have some technical superiorities to cash. When you have cash, it's more easy to steal. You just have to see where the money is and take it away. You can steal a wallet, you can break in someone's house and take away the money. It's easy to confiscate. So a government can freeze your bank account, or they can raid your house and take away your money. And it is also, for people with the right skills, possible to counterfeit money. These things are very hard to do with cryptocurrency. What you also have with the blockchain is that it cannot, like the big public blockchains, they cannot be replicated by big organizations or big governments, even if they would throw all the resources they have at it. Because an organization could, in theory, come up with a technical, superior or perfect blockchain. And the blockchain is only valuable if it is used by many people. That's called the network effect. It's the usage of the blockchain that give value to it. And one organization coming up with a blockchain will not have the same usage as the big public blockchains that are used already. So it is not possible for someone to replicate the big blockchains in existence now. Also, the big public blockchains are designed in such a way that they cannot be controlled by a government or a big organization, so they allow for some security in that way that you can own your assets without someone else having control over it. These are three benefits that are very difficult to replicate. They have their value, and that is why blockchains will be here to stay. The biggest public blockchain is Bitcoin. It's the first popular one. Bitcoin was launched after the 2008 financial crisis, and the aim of Bitcoin was to be an alternative to money, to fiat currency issued by central banks. The focus of Bitcoin is in storing money and payment transactions, so only that. It wants to be an alternative to cash, to existing money. And the consensus mechanism of the Bitcoin network is proof of work. This will not change in the foreseeable future, and that is because the miners, they have the decision power over the Bitcoin network. The miners, they have invested in hardware to do proof of work, and because they have the hardware and they have, they get all the rewards for the proof of work consensus mechanism. If the miners were to decide to convert to a proof of stake consensus mechanism, then their hardware would become obsolete and they would have to share the rewards with other people. So it is not in the miners' interest to switch from a proof of work consensus mechanism to a proof of stake consensus mechanism. That's why Bitcoin in the foreseeable future will keep using proof of work, though proof of stake is often considered to be a better consensus mechanism for a blockchain. The second biggest blockchain is Ethereum. Ethereum was designed because people wanted to do more than only store payments and payment transactions on a blockchain. They wanted to be able to run programs and be able to program whatever they wanted. So Ethereum has more functionality than Bitcoin. In Ethereum, you can write programs. You can program whatever you want to do. In practice, there is a limitation on it, because whatever you do on the blockchain, it costs money. If it's something complex you want to do, you have to pay a lot of money. So there is a limit on what you can do, because the costs what you want to pay are limited. Therefore, typically programs on the Ethereum blockchain are very small, and these small programs are called smart contracts. Ethereum started with the proof of work consensus mechanism. It had always planned to switch to proof of stake, but because proof of stake is technically much more complex, they started with proof of work. And then eventually, after 7 years, Ethereum switched to proof of stake. Here is a roadmap of Ethereum on how it is planned to change in the future. So there are 6 planned phases: the merge, the search, the scourge, the verge, the purge, and the splurge. The merge is a first phase and is finished, and was about switching the consensus mechanism of Ethereum from proof of work to proof of stake. This has been done. The search is about making the Ethereum blockchain more efficient. There are 2 ways how they plan to do it. One way is through sharding, and the other way is through rollups. Sharding is, simply said, splitting up the blockchain in multiple blockchains that can be processed in parallel. Rollups is about not doing all the work on the blockchain, actually trying to do as much as possible outside of the blockchain, and then only store on the blockchain what is needed, so as little as possible. Sharding is a concept that is already established, because you have an analogy in databases. Rollups are a new technology. It is still in development, so it is not clear yet where what will be the final solution there. With sharding, the performance of Ethereum is expected to increase about 1,000 times. So now you have about 15 transactions per second. This could be increased to maybe 15,000 transactions per second with sharding. But because people want to increase the performance even more, they are also using rollups, and then the ambition is to eventually have over 100,000 transactions per second in the Ethereum blockchain. The idea is also, if the Ethereum blockchain becomes more performant, the cost of doing things on the blockchain will be lower and the usage of the blockchain will increase. The scourge is about making it harder to game the system. So what you have now in theory in the Ethereum blockchain is, if 2 people want to do something at the same time, one of these people can actually try to have his transaction take priority over the transaction of the other person. For example, if on the blockchain you can buy something for cheap, 2 people want to buy it, then one person can actually make sure that he buys it, and on the other one, by giving the validators a higher transaction fee. It are the validators that decide which transactions go in a block on the blockchain, and of course validators want to make money, so they will typically prioritize transactions where there is a higher transaction fee. So one person can game the system by paying a higher transaction fee than someone else, and to make this kind of prioritization of one transaction over another more difficult, that is what the scourge is about. So it will become very hard to prioritize one transaction over another. The verge is about simplifying the verification on the blockchain. This will mainly help the validator nodes. It will also reduce the hardware requirements for the validator nodes so that less hardware is required to run a node, and this should also help with the decentralization of the blockchain. The purge is about eliminating technical debt. Every code base, so every software, has ugly code, like obsolete code that is not used anymore, or code that is hard to read or hard to maintain. And the purge is about cleaning up the code and making the code easier to maintain. The splurge are for things afterwards that are currently not seen as priorities, but Ethereum is planned to keep evolving after, and that is what the splurge is about. In the last slide here, I want to explain the transaction costs in Ethereum. Whenever you execute a function on the Ethereum blockchain that makes some changes to the blockchain, you have to pay some money, and this money is calculated as the gas of the function multiplied by the gas price. Every function on the blockchain is compiled to basic operations of a virtual machine, which is called the Ethereum virtual machine, and each of these basic operations have a gas cost associated with them. The gas cost of executing the function is the same as the sum of the gas costs of the basic operations to which the function has been compiled. Once you know the gas for executing a function, you also have to look for the gas price, and the gas price is set for each block. It varies per block, and the gas price is executed in gigawatt. 1 gigawatt is a billionth of an ether. And if you multiply these two things with each other, so gas multiplied by gas price, you find the total amount of money you have to pay. As an example, to store 1 kilobyte of data on the Ethereum blockchain costs 707,200 gas, and a typical gas price of a blockchain is 25 gigawatt. So if you were to store 1 kilobyte of data on the blockchain with the gas price of 25 gigawatt, you would have to pay 0.01768 ether. If an ether is around 1,700 US dollar, then you would have to pay about $30 to store a kilobyte of data on the Ethereum blockchain. You see, for big files like pictures or videos, you would have to spend a lot of money. You could store a picture of a couple of megabytes on the blockchain if you really wanted to. Technically it's possible, but you will have to pay hundred thousands of dollars, and for videos it will be in the 100 millions of dollars. So you see, this is a very costly thing, and that is why the Ethereum blockchain, or a blockchain in general, is not suited for storing any data. It's only suited for storing data that has a high value but that does not have a lot of storage requirements.